Okay, number 3. The graphs of two rational functions. We've got f of x and g of x down here. F of x on the left, g of x on the right. Right there's f of x and g of x. And they're saying one of these can be described as this function right here, 2 minus 3x over x. Which graph is it? We're just picking which one of these graphs represents this little function right here. Let's write that down over here. 2 minus 3x divided by x. Okay. Here, first off, let me mention something real quick, all right? It's not going to help us particularly with this one, but notice right here. Look, if we make x 0, we can't divide by 0. So if you can't divide by 0, you get this little vertical asymptote. What you're going to get is, and the way we usually represent that in math is we'll put like a little dotted line, but we don't have the dotted line here. See, we got these two horizontal dotted lines right here and here, which is representing the end behavior. But they didn't put a vertical asymptote, a dotted line for our vertical asymptote right here, where x can never be 0, because we never divide by 0. So both of these are accurate as far as the denominator goes. So that's not going to help us solve this right here, because the denominator, it's the same for both. X is never going to be 0, because we can't divide by 0. So the clue must be in the end behavior. What's causing this graph to be approaching, looks like positive 3 over here on g of x, and in f of x, it's approaching negative 3. As x gets really, really, really big, x is going to get, or no, I'm sorry, y is going to get super close to negative 3 on f of x. And on g of x, as x gets really, really big, or really, really small, y is getting closer and closer to positive 3. So let's divide this out. Let's see what happens when we divide this and we get some constant plus the remainder. All right, look, we can't divide 2 by x. Okay, if it was 2x, we could, but we just got 2 over x. It's gonna be stuck up there, and like as a fraction, that's up there in the numerator. But look, we can get 3 out of there. This minus 3 is times x. I could divide that by x and just get negative 3. So let's simplify this. What this is, it's kind of a I forget what they call those, for improper fractions. This is sort of an improper fraction here. We could simplify it. 3x divided by x is 3. Oh, we gotta remember, we gotta be really careful. Notice it's negative. Okay, don't forget that it's a minus 3x. So we're getting closer and closer to negative 3 as x gets larger and larger. Let's finish. We're simplifying this. We got this remainder of 2. We couldn't get 2 out from under, or out from on top of that numerator. So it's still stuck over top of x. And it's positive. Okay, why is 2 positive? Because there's no negative sign out front. If there's no minus in front of the 2, no negative in front of the 2, it's actually positive 2 minus 3x. So the negative comes from right there, but the positive comes because the fact that this 2 is positive. And it doesn't really matter if it's plus or minus 2 over x, because when x gets to be really, really large, like 1,000 or 1,000,000, this 2 is getting sliced into 1,000,000 little tiny slices. It gets smaller and smaller, closer and closer to 0. And x, or y, in this case, g of x, or no, I think it must be f of x, is getting closer and closer to negative 3 down here. So f of x is our solution right here. This is the one that looks like this equation, because it has an end behavior of negative 3. Y is getting closer and closer to negative 3 as x gets larger and larger.